Hello students, in today's video we will discuss about power of a lens. Power of a lens is the measure of convergence or divergence which a lens introduces in the light falling on it. That means how much it bends the light falling on it, that is the measure of the power. So power of a convex lens is, for a convex lens power is positive. And for a concave lens, the power is negative. Now, how to find the power is equal to 1 by f, that is the reciprocal of focal length. This focal length should be expressed in meter. So, power of lens is reciprocal of focal length and its unit is diopter. So, if a lens, for example, we are getting plus 2d diopters as its power. This means it is from the sign of this you can understand that this lens is a convex lens, and sometimes you will be asked to find the focal length. So focal length is 1 by p, that is 1 by 2, that is 0.5 meters. So it will be 50 centimeter. Similarly, if you are given with another question in which power is minus 1d, that means minus shows that it is a concave lens and the focal length is 1 by p, that is 1 by minus 1, which is 1 meter or 100 centimeters. So negative focal length means it is a concave lens. This is positive focal length, convex lens. That is how we find the power of a lens. Now, in combination of thin lenses in contact, if there are two lenses in contact, the separation is very minimum. In that case, we can find out the total power produced by these two lenses in contact. So, let us imagine there are two lenses A and B. The object is a point object at O on the principal axis. It is at a distance u from both the lenses because the lenses are very thin and in contact. Therefore, we take the distance to be u from both the lenses. Now you can see there are two images. One is called I1 and the other is known as I. So what is I1 is the image formed by the first lens called A, which had a real object in front of it. Now the lens B doesn't have any object of its own. So what it will do is it will take the first image formed, that is I1, as its object, and it will form its image finally at I. So you can see that there is a V distance given here. V1 is given. V1 is actually the image distance of A as well as the object distance of B. And final image of B is formed at I, which is at a distance V from the lenses. So we'll find out how to calculate the focal length, total focal length of this combination. So what will we do is for the first lens A, for A we will write, for lens A, the focal length formula we will write 1 by f is equal to, we'll call it as 1 by f1 is equal to 1 by v1 minus 1 by u1. So what is v1 and u1 here? v1 is v1 itself, u1 in this is u. So we can write it as 1 by v1 minus 1 by u according to the figure. So this is our first equation. Now for B, lens B, we will write the formula, that is 1 by f2 is equal to 1 by v1, that is instead of v1 what we have here is v. So we'll put v minus 1 by u1. Instead of u1 we have v1 here. So we'll put 1 by v1. This is our equation number 2. So f1 and f2 are the focal lengths of these lenses A and B respectively. Now we will add these two equations 1 and 2. So what we get is 1 by V1 minus 1 by U plus 1 by V minus 1 by V1. So 1 by V1 and minus 1 by V1 get cancelled, and this gives us 1 by V minus 1 by U. So what we have done is actually we did 1 by F1 plus 1 by F2. So when we did that only, we got 1 by V minus 1 by 1 by V minus 1 by V is 1 by F. So what is the inference? 1 by F1 plus 1 by F2 is equal to 1 by F. That means when we keep lenses in contact, their powers are getting added up. 1 by F is the total power, 1 by F2 is the power of the lens 2, 1 by F1 is the power of the lens 1. So P is equal to, we can say, P1 plus P2. So if there are many lenses in contact like this, what we can do is we can add them all. P will be equal to P1 plus P2 plus P3 plus etc. But in case if there is a convex lens concave lens combination, convex is positive. For example, the first lens let us imagine we have a combination of three lenses. One is a convex lens, then comes a concave, then again a convex. Like this combination means its power will be P1 minus P2 plus P3, because one of the lens is a concave lens here. This one is a concave lens, so it has a minus power. So like this you should add. What about the magnification of this? For example, in this case the two lenses, magnification will be the product of the magnification produced by each of them. So power is a sum, at the same time the magnification is a product. In this question, a converging lens is kept coaxially in contact with a diverging lens, both the lenses being equal focal length. What is the focal length of the combination? There are two lenses. One is a converging lens and the other one is a diverging lens. So f1 is a converging lens, we will take its focal length as f, and f2 is a diverging lens, its focal length will take as minus f. So according to the lens contact formula, 1 by f is 1 by f1 plus 1 by f2. So here it will be 1 by f plus 1 by minus f. So this will give us 0 as the result. 1 by f is equal to 0. That means the power is equal to 0. Or what about the focal length? Focal length will be 1 by 0, that is infinite. In the next question, what is the focal length of a combination of a convex lens of focal length 30 cm and a concave lens of focal length 20 cm in contact? Is the system a converging or a diverging lens? Ignore the thickness of the lenses. So we have two lenses. One is a convex with f1 is equal to 30 centimeters. That is a positive one because it's convex. Now concave lens f2 is equal to minus 20 centimeter. So what we do is 1 by f is equal to, as before, 1 by f1 plus 1 by f2. This is 1 by 30 plus 1 by minus 20 is equal to, it is f1 f2 divided by f1 plus f2. So it is 30 into minus 20 divided by 30 minus 20. So it is equal to minus 600 divided by 10, which will give us minus 60 centimeter as the focal length. So it's a negative focal length, so that means it will be a diverging lens. So the final answer we have to do diverging lens. This question, a screen is placed 90 centimeter from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeter. Determine the focal length of the lens. So we have given with 90 centimeter is a screen's distance from the object. That means it is u plus v is equal to 90 centimeters. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeters. So there is a distance given there, 20 centimeter. Let us imagine it as x between the two images. The distance is given as 20 centimeters. So in such cases, this one u plus v we can take as equal to d. So there is a shortcut formula for finding the focal length of this lens combination. It is f is equal to d square minus x square divided by 4d. So what is d here? D is the object to image distance, which is given as 90 centimeter, and x is the displacement between two images formed by the lens. So x is equal to 20 centimeter. F is d square minus x square by 4d. D is 90 square minus x is 20 square divided by 4 into 90. So this will give us the value as around 21.4 centimeters.